Welcome, chemistry students. This is Mr. Christopher, and I'm going through some example stoichiometry problems for you. This one happens to be from lesson 79, section 3.2. This is an FRQ practice problem, and we're going to look at the steps needed to do this type of problem. So the first thing is you always need to have a balanced equation. And so we've got a balanced equation here. It was provided in the problem. On that particular balanced equation, we're asked to see if we can find, we're given 180.67 grams of nitrogen, and we're asked to see if we can find how many grams of NH3 or ammonia would be produced. So when we do this, we always want to set up a proportion where we put what we have over what we want. And this proportion here works out really well due to the law of conservation of mass. The only thing that's a little tricky about this is remembering what goes on the right side. So the way we remember this here is molar mass, that's the M, Avogadro's number, that's the A, and the ratio, that's the R. And so to remember this, we just remember that Mars is a planet that maybe someday NASA will go to, and easy way of remembering that acronym MAR. And then we put an S on the end because we always want to use the ratios. And the same is true on the bottom. Whatever you got on the bottom, just make sure the units match for the substance you're talking about. So in this case, we've got this many grams of nitrogen. So what we want is the grams of NH3, so we put that on the bottom. Now I use the variable X, doesn't matter what variable you use. And then the molar mass, since we have grams of nitrogen as our have, we want to use the molar mass. If we had particles, we'd want to use Avogadro's number. And if we had moles, we would just use the ratio. The ratio is important to use every single time, so make sure you include it every time, and we'll get to that in a moment. So I look up on the periodic table the mass of nitrogen, which is 14.01. However, it's N2, so you always do it based on the formula, which would be 14.01 plus 14.01, or 28.02. Next step I'm looking at is Avogadro's number. Now, would we include Avogadro's number because we have grams here? So because we have grams here, we would not include Avogadro's number. The only time you would include it is if you were looking at particles or even atoms. The last one is the ratio. We do want to include the ratio every single time. So if I look up here, nitrogen, right here it says that there are 2 nitrogens in the balanced equation. Sorry, not 2 nitrogens. How many nitrogens are in the balanced equation? That is over here, and it's an invisible 1. So this here that goes on the top would be 1 mole of nitrogen. And so I put it in black there to signify it's not the same thing as the 2 on the other side. On the bottom, we've got NH3. We want to find out how many grams of NH3, so what do you think we would use? Would we use molar mass? Would we use Avogadro's number? Would we use the ratio? So for the NH3, molar mass, this says grams. We would use the molar mass, not use Avogadro's number, but always use the ratio as well. So it would look like this, 17.04, that's 1 N and 3 H's from the periodic table. The 2 moles, that's the one that's right here. And you can see here we set up a proportion. Next step would be to cross multiply. So it's 180.67 grams times 17.04 times 2. And then that equals the 28.02 times 1 times Rx. And so Rx is over here on this side. To solve for x, we divide both sides by the 28.02 and both sides by the 1, and we should get an answer of about 219.744 grams of NH3. In this particular problem, if you're doing it on a computer, usually you can type it all in. If we were using significant figures, that would be 5 significant figures, and this would round it to 19.74 grams of NH3, and that's how to do a stoichiometry FRQ problem. Thanks for listening. Hopefully you can subscribe and catch some more videos on Chemistry Help. If this was helpful, thanks for giving it a thumbs up. I appreciated it, and hope this helps. Have a good day. Bye-bye.